Take.
How's it going? This is take 2 of using a volumetric pipette and trying to find the actual volume delivered using the mass and converting it to density. So first thing we're going to want to do here is measure the temperature in Celsius of this deionized water here. So we're going to get down nice and close, throw the bottom of the thermometer into the water, and give it a moment to sit there and find the temperature. Okay, so the temperature reading looks like it's at about 21.0 degrees Celsius, if you can see that on the camera.
Uh-huh.
So, next thing we're going to do is mark that down. Next thing we're going to do is we're going to measure the mass of this 50 milliliter beaker we're going to be using to contain 10 milliliters, or about 10 milliliters, of this deionized water. First thing we're going to want to do is tear the scale. Then we're going to place the beaker on. And we get a mass of 29.348. You got that? Okay. Next thing we're going to do is pipette 10 milliliters of this water. First thing we're going to do is attach the volumetric pipette to the pipette pump. We're not going to go for like a very tight seal here, just enough so that it seals when you add the when you create the vacuum. So what we're going to do is suck up some of the water here by pulling this down here. We're going to get to this line right here. So the idea is you want to get above the line, but not into the pipette pump. So we're going to lower the volume here until it hits the meniscus. So ever so slightly. And there we go. If you saw that on the camera. Okay. Now, we're going to be using a Kim wipe. Just get that last drop off so we get a near exact volume. And then we're going to be unloading into here by releasing our pointer finger to empty the vacuum and let all the water out. And empty the vacuum and allow the air in. So there goes the last of our water here. So now we're going to measure the mass. We're going to keep the scale on the same tear and measure the mass of the beaker with the water. And that comes out to about 39.295 grams. And then we're going to want to get the difference. So we're going to do mass final minus mass initial. And we get 9.947 grams of water. Alright, so next thing we're going to do is look up the density of water at that temperature. We record the temperature to be at 21.0 degrees Celsius. So we're going to go down to 21, over to 0.0, and our density is 0.997992. Alright, so we're going to use this as a conversion factor here. So we're going to do 9.947 grams of water times 1 milliliter per 0.997992 grams H2O, that is. And we get 9.967 mils of water.